Hello everybody, Jean-Philippe speaking. Well, today I want to talk about digital assessment, of course, but it's particular because I want to show you for the first time a project. I'm working on it for a few months now, and this project is WASPL. The WASPL platform is a sort of a Swiss knife of digital assessment. It is modular and it allowed you to experiment and try a lot of ways to solve needs and problems. But to have a better presentation, first I will disappear. Don't worry, I'm still here to guide you through this application. Now, let's take a look at the test section. As you see, we can create a new test here using the form or importing a JSON. The test list can have different filters and a pagination tool to manage numerous entries. To edit a test, just click on it. Let's open the climate change quiz. In the test parameter section, you can edit options that will change the behavior of the test runner. For example, you can activate a progress bar or a navigation panel. You can shuffle pages, add a countdown, or select a preset mode. Now, let's take a look at the editor. The editor is built on a page-based logic. We can scroll through it and see that there are 4 pages. On each page, we have different elements. These can be either simple messages or real interactions. Here, for example, we can recognize the choice interaction. Here, the text gaps or the order interaction. If we are not satisfied with the order of the elements, we can rearrange them using the drag and drop system in or through the pages. We can take an element from one page and move it to another, making it easy to reorganize your test. Let's select this question, still based on choice interaction. We have here the question: what is the main cause of climate change? And here there are different options. We can see here the right answer. 10 points are given for a good answer. For bad answer, it is also possible to give negative points, penalties. Of course, you can delete or add more options. I add the possibility to use a hint to help the student. If it is activated, it will modify the render. Even if this example is simple, that shows how relevant is immediate render preview. You can control exactly the final result in real time. But the most important is the possibility to visualize actions when the question is submitted. Clicking on Submit button, here the feedback is basic. It shows you what element will be sent to the database, the answer chosen, the score, the max score, the use of the hint, but it can be much richer. Let's have a look now to the short answer interaction. It is very simple. It is an open-ended question. As other interaction, the preview and the editor are available. You can add a text or an image, any stimulus you need. But in addition, this interaction has the particularity it will be corrected by the AI. If we scroll down to explore the short answer features, we can find an explanation of how AI correction works. However, let's focus on the core principle that structures the correction method. It is simple. The idea is to break down the complexity of the answer into closed sub-questions. By closed, I mean questions that the AI can evaluate as true or false. This approach is commonly used to correct open-ended questions. The item creator must define specific elements that the corrector should verify. This ensures a more objective and structured correction process. The correction grid here consists of verification axes. The item creator can create as many axes as needed and define the corresponding points or penalty for each. In this example, I have defined the correction grid with 4 verification axes. The first one, the IPCC report, is mentioned. Second one, weather and climate, are clearly distinguished. Third one, at least 2 valid examples are provided. And the last one, the answer is focused. For this example, I have deliberately chosen factual and less precise correction axes to illustrate the research on this specific point. Let's simulate now the student answer. Here it is. I keep myself informed by watching the weather on TV, listening to it on the radio, and reading it in the newspaper. The weather is the best way to keep up to date with climate change. This answer has a problem. It seems that the student is confusing weather and climate. Let's simulate now the AI correction. I'm clicking on Submit. It is calling the local AI API. Here are the axes treatment. Each one has the Boolean estimation and an explanation of their choice. In addition, we can see the score. As we can see, all the sub-answers are considered wrong with negative scores. When we take a look at the justifications, some appear to be indisputable. The IPCC report is not mentioned. It should be noted that the examples of reference sources are judged as non-specific and that the answer is rejected. It should also be noted that the confusion between climate and weather is identified and sanctioned. Under the AI correction, we can inspect the technical part of the AI request. We can see the final prompt that grabs information at the test level, the subject, the student grade. The main question and the answer are sent. Also, the last axe. The request is sent separately for each axe. Note the capacity of the AI to produce a JSON format. This technical point could be a challenge, but it's crucial to reuse the results to calculate the global score. Under the final prompt, we have the AI model used. In this case, DeepSeek R1 Distill Qwen 7B. I can briefly explain this choice. WASPL uses ML Studio and its API in a local setup. No internet connection. No data sent outside. This means the WASPL administrator can select any model he wants, and more importantly, keep up with the rapid evolution in this highly competitive field. Some AI API providers are both affordable and efficient, such as Google and Gemini, while others, like OpenAI, can be more expensive. So pricing is constantly evolving. However, data security and confidentiality can be a concern. To keep your test secure, it is recommended to use a local solution. A local setup also offers the significant advantage of giving you the full control over cost and drastically reducing expenses. I won't go into further detail about AI request temperature and max token, but keep in mind that these are important parameters for achieving better response quality. The example clearly showed that artificial intelligence could be a very interesting solution, but its use actually raises many questions. The first question is the consistency of the results. That is central because a good correction must verify the equity principle. In human correction, we try to reduce the lack of consistency between correctors with clear instruction, cross-correction, correction supervision, and identification of corrector profiles. To illustrate this issue, let's press a second time on the Submit button. The axis, at least 2 valid examples are mentioned, has been evaluated as true. In the previous correction, it was considered false because it was not specific enough to the topic of climate change. This time, TV and radio shows about the weather are considered a possible source of information. That is not entirely incorrect. On the contrary, weather shows now often provide examples related to global warming. So, what do you think? Is the problem coming from the AI or from the way the correction axis was defined? Given this variation, the item creator can now adjust the axis definition and precisely specify what is expected. We could explore other variation, but time is running and this video is already too long. I would like to emphasize that the integration of a response analysis simulator at the editor level is clearly relevant. Of course, it is also possible to adjust the judgment of the AI in another way, changing the AI model, changing the temperature or the max token value. These adjustments are easy to test and use. It could be also possible to create a specialized AI fine-tuned based on the didactic content to assess. Despite the significant existence of big data in education, the development of a specialized model for correction in the different areas seems to me economically utopian, but technically totally possible. Voila! My proposal was to explore through this new platform a pragmatic solution for the rapid implementation of artificial intelligence as a correction tool. I hope you found the topic interesting. Let me know what you think. I'm looking for collaboration and fundings to further explore this field and expand the WASPL platform under an open source freemium model. My next video will cover the main features of WASPL that are already available, with a special focus on the item library. Thank you. Feel free to reach out if you have any question. Thank you again.